"You are obsolete, Derek. Pack your bags and get out right now," the plant manager screamed, slamming my pink slip onto the desk. I stood up, handed over my laptop, and walked away. They thought they fired an engineer, but they just unplugged their factory. To understand how we got here, you have to understand what goes on inside Vanguard Injection Molding Corp. We are located in a gray, flat stretch of Columbus, Ohio, in a 90,000 square foot facility that smells of heated polycarbonate, hydraulic oil, and ozone. We run 24 hours a day, 7 days a week, stamped by the rhythmic, deafening thud of 24 massive angle injection molding machines. These machines aren't simple toys. They are hydraulic beasts, applying 700 tons of clamping force to fuse melted plastic into automotive components. For 15 years, I worked as the lead tooling and design engineer at Vanguard. I was hired by Harrison Sinclair, the original founder. Harrison was an old-school engineer who built the company from 3 manual presses in a garage. He knew that precision was the only thing that kept us alive. If you are making plastic cups, a variation of 1/10 of a millimeter doesn't matter. But Vanguard doesn't make cups. We make glass-filled nylon engine harness connectors for Ford and General Motors. These connectors house 48 tiny electrical pins that feed data to the engine control unit. If a connector warped by even a fraction of a millimeter during the cooling process, it wouldn't click into place on the assembly line. A single bad batch could halt a vehicle assembly line, costing the manufacturer $50,000 an hour in downtime. Ford would pass that cost directly back to us, along with a massive penalty fee. My job was to ensure that never happened. Injection molding is a delicate balance of thermodynamics and metallurgy. When you inject molten plastic at 300 degrees Celsius into a steel mold at 20,000 pounds per square inch, the plastic shrinks as it cools. If the steel mold cools unevenly, the plastic part warps. The steel molds themselves are massive, complex blocks of H13 tool steel, costing upwards of $80,000 each. They are drilled with intricate water channels to control the temperature. Years ago, before I became a full-time employee, Harrison hired me as an independent contractor through my single-member firm, Holt Precision Design LLC. The German-made angle machines had standard temperature controllers, but they couldn't handle the micro variations in the cooling cycles of the complex multi-cavity molds we used. The factory was running a 7% scrap rate, which was eating our margins alive. Harrison paid me $50,000 to write a custom software solution. I spent 6 months writing a proprietary Python script called HoltCalib E4.2.py. The script ran on a local Windows server in the plant's server room. It connected directly to the PLCs, the programmable logic controllers, of all 24 angle machines through an OPC-UA industrial communication protocol. Every millisecond, the script read data from thermocouple sensors embedded deep inside the mold cavities. It dynamically calculated the heat expansion coefficients of the steel and adjusted the electrical currents to the heater bands on the machine barrels. It was a beautiful piece of engineering. It brought our scrap rate down from 7% to a microscopic 0.05%. When Harrison saw the results, he offered me a full-time job as the lead tooling engineer with a comfortable salary of $130,000. I accepted, but being cautious, I had my lawyer draft a specific software license agreement for the calibration script. The script remained the intellectual property of Holt Precision Design LLC. Vanguard was granted a non-transferable corporate license to use the software, but the license was explicitly tied to my active employment. The agreement stated that if my employment was terminated for any reason, Vanguard had to pay a $250,000 buyout fee within 10 days to retain the license. If they failed to pay, the license would automatically revoke, and any continued use of the code would constitute willful copyright infringement under Title 17 of the United States Code. Harrison signed it without hesitation. He had no intention of firing the man who made his factory work, but things changed 2 years ago. Harrison's health began to decline, and he stepped back from daily operations, leaving the company in the hands of his son, Julian. Julian had a degree from a top-tier business school, a wardrobe of tailored suits, and absolutely no understanding of how plastic actually melted. He saw Vanguard not as a precision manufacturing house, but as a spreadsheet of expenses that needed to be trimmed. Julian's first major move was to bring in Braden Cole as the new plant manager. Braden was a self-styled operational efficiency expert. He arrived at the facility carrying a tablet loaded with charts, talking endlessly about synergy, lean manufacturing, and outsourcing. He looked at my salary. Then he looked at the cost of our local tool and die suppliers who machined our molds, and he saw dollar signs. Braden and Julian immediately targeted our tooling department. They proposed outsourcing the fabrication of all future injection molds to Sinomold Solutions, a low-cost supplier in Shenzhen. I protested immediately. I explained that the steel quality from low-cost overseas suppliers was inconsistent, and the cooling channel designs were often flawed. I told them that our angle machines were calibrated for premium domestic steel, and that using cheaper molds would cause massive thermal imbalances. Braden just smirked at me. "Derek, you're living in the past," he said, tapping his stylus on his tablet. "Sinomold guarantees the same tolerances at 40% of the cost. Your local suppliers are overcharging us, and your warnings are just an excuse to protect your friends in the local machine shops." Julian nodded in agreement. "We need to modernize, Derek. We can't let sentimental attachments to old ways of working hold back our quarterly margins. We are moving forward with the Sinomold contract." I knew right then that trouble was coming. I spent the next 3 weeks documenting every system configuration and backing up the source code of Holt Caleb E4.2 Pi on my private encrypted server. I kept doing my job, monitoring the machines and ensuring the current Ford production run was flawless. But I knew that Braden and Julian were already planning to replace me. They didn't want a senior engineer making $130,000 pointing out the flaws in their spreadsheets. They wanted a cheap operator who would just press the green button and keep his mouth shut, and they were about to get exactly what they asked for. The conflict began when the first batch of molds from Sinomold was scheduled for delivery. Julian Sinclair wanted to brag to his father, the CEO, about the massive cost savings on his very first project. Braden Cole, eager to secure his quarterly performance bonus, realized that keeping my salary on the books for another month would eat into the operational efficiency metrics he had promised Harrison Sinclair. On a rainy Thursday morning, Braden sent me a calendar invite for a production review at 10:00 a.m. in the main conference room. When I walked in, I saw Julian sitting next to Braden. In front of them was a single manila folder and my employee file. I knew exactly what was happening. Braden didn't even ask me to sit down. He cleared his throat, adjusted his tie, and tapped his tablet. "Derek, we've been reviewing the department budgets for the upcoming quarter. As you know, we are transitioning our tool fabrication to our overseas partners. This means your role as lead tooling engineer is being restructured." I pulled out a chair and sat down anyway. "Restructured or eliminated?" Julian spoke up, his voice dripping with condescension. "Let's be frank, Derek. You've been a bottleneck. Every time we try to optimize our supply chain, you raise objections. You refuse to sign the vendor safety and compliance certification for the Sinomold shipment last week. That delayed our customs clearance by 4 days. I refused to sign it because they didn't provide the Charpy impact test results or the chemical composition reports for the tool steel," I said, keeping my voice level. "If we run molds made of cheap, low-grade steel under 20,000 psi of clamping pressure, they can crack. If they crack while under pressure, they will destroy the platens on our angle machines. That's a $500,000 repair per machine." Braden waved his hand dismissively. "Sinomold is an ISO 9001 certified manufacturer. Your refusal to sign was nothing more than insubordination. You are deliberately trying to sabotage this transition to prove a point. We cannot have key personnel actively working against the company's financial interests." He slid the manila folder across the table. I opened it. It was a termination letter for cause. It cited insubordination and refusal to perform core job duties, specifically referencing my refusal to sign the compliance documents. Because it was for cause, there was no severance package, no 3-month transition pay, no payout for my unused vacation days. Just an immediate termination of my employment and benefits, effective at noon. "We are offering you a choice," Braden said, leaning forward. "Sign this acknowledgement, and we won't dispute your unemployment claim. If you don't, we will fight it, and we will make sure your next employer knows exactly why you were let go." Julian leaned back in his chair, a smug grin on his face. "We've already hired a replacement, Derek. Tyler, our new automation technician, starts next week. He's 24, has a certification in basic PLC coding, and is eager to learn, and he's doing it for $22 an hour. The reality is, the Python code you wrote does all the heavy lifting anyway. We don't need to pay you $130,000 a year to watch a monitor." I looked at the document, then at Braden, then at Julian. They honestly believed that my 15 years of metallurgical experience, my knowledge of thermal dynamics, and my understanding of the machine's physical quirks could be replaced by a kid with a 3-week certificate and a script I wrote 5 years ago. They thought the software was a magical black box that just worked. They had no idea that Holtkalib A4.2.py required constant adjustments to the offsets because the heating bands on the older Engel machines degraded over time, or that the local grid voltage fluctuated in the afternoons, requiring minor code overrides to prevent thermal spikes. I didn't argue. I didn't tell them they were making a catastrophic mistake. If I tried to explain the software license or the calibration complexities, they would just accuse me of threatening them. "I see," I said. I pulled my pen from my pocket, signed the acknowledgement line stating I received the letter, and pushed the folder back. I reached into my pocket, pulled out my encrypted USB keycard, my physical building access fob, and my company-issued phone. I laid them neatly on the table. "My personal toolbox is on the shop floor," I said. "I assume I have permission to retrieve it?" "Security will escort you to your desk and then out of the building," Braden replied, gesturing to the HR representative who had been standing quietly by the door. "Your company laptop stays here." "Of course," I said. I stood up, smoothed my jacket, and walked out of the conference room. My escort, a quiet HR assistant who looked incredibly uncomfortable, followed me down to the tooling bay. The shop floor was deafening as usual. The massive Engel machines cycling every 28 seconds, dropping finished wiring connectors into green plastic bins. My team of technicians looked up as I walked by, sensing something was wrong. I didn't say anything to disrupt the shift. I just unlocked my rolling toolbox, locked the drawers, and pushed it toward the loading dock. I loaded my personal tools into the back of my truck. At exactly 11:45 a.m., I drove out of the Vanguard parking lot. I parked across the street at a local diner, ordered a black coffee, and pulled out my personal tablet. I opened a command terminal and logged into the remote monitoring portal of Holt Precision Design LLC. I checked the server status. The local server at the Vanguard plant was still communicating with my private database. The active API token, which authorized the Holtkalib A4.2.py script to pull calibration tables from my server, was showing green. I looked at my watch. It was 12:05 p.m. My corporate credentials had officially been deactivated. My name was wiped from the Active Directory. I opened the software licensing portal. I pulled up the agreement Harrison Sinclair had signed 5 years ago. I clicked on the active Vanguard license profile. Under the terms of the agreement, my termination without a buyout triggered a license violation. I hovered my cursor over the button marked Suspend License. They wanted to run a $1 million production line on my code, while paying a kid $22 an hour to watch it. They wanted to save a few pennies by throwing me out like garbage. I clicked the button. When I clicked Suspend License on the admin dashboard of Holt Precision Design LLC, I wasn't venting anger. It was a calculated business decision. The software license agreement Harrison Sinclair signed 5 years ago was clear. The license was contingent upon my employment. The moment Braden Cole handed me that termination letter, the contract's termination clause was activated. Let me explain the technical architecture of how this worked. The Holtkalib A4.2 Pi script didn't run on my laptop. It ran on an industrial PC located in the climate-controlled server room of the Vanguard facility. Every time one of the 24 Engel machines started a new cycle, the local script sent an HTTPS post request to my private server, auth.holtprecision.com. This request contained a cryptographic hash of the machine's MAC address and an active API token. If my server returned a 200 OK status with a signed verification payload, The script would feed the dynamic temperature offset tables into the machine's PLCs. These offset tables were calculated based on the specific material viscosity, room temperature, and humidity sensors. But if the server returned a 403 forbidden status, the script was programmed to enter what we call factory default mode. FIDE default mode didn't shut the machines down. I didn't want to be accused of malicious hacking or sabotage. That would be illegal under the Computer Fraud and Abuse Act. Instead, the script simply stopped modifying the temperature variables. The machines reverted to their built-in manufacturer calibration tables. If Vanguard was running simple, thick plastic parts with wide tolerances, they wouldn't have noticed a difference. But they were running high-precision glass-filled nylon automotive connectors. Without my active thermal feedback loop, the machines would run hot and cold, causing the molten plastic to cool at unpredictable rates. At 1 p.m., I drove to the law offices of Robert Grant in downtown Columbus. Robert had been my corporate attorney for a decade. He was a sharp, gray-haired man who specialized in intellectual property and manufacturing contracts. He had the original Vanguard contract on his desk when I arrived. "They really did it, didn't they?" Robert asked, taking off his glasses. "Braden Cole fired me for cause," I said, sitting across from him. "He claimed insubordination because I refused to sign off on the Sinomold compliance documents. No severance, no buyout." Robert shook his head and laughed. "Braden is a plant manager, not a lawyer. He has no idea what he just signed. The software license agreement is explicit. Termination of employment, whether for cause or convenience, immediately suspends the license. Vanguard has 10 business days to cure the default by paying the $250,000 buyout fee. During those 10 days, the software license remains suspended. If they attempt to bypass the authentication or continue running the script, they are in direct violation of federal copyright law. I suspended the API token 10 minutes ago," I told him. "Good," Robert said, pulling up a template on his computer. "I am drafting a formal cease and desist letter right now. I will have it hand-delivered to Harrison Sinclair, Julian Sinclair, and Braden Cole by 3 o'clock this afternoon. The letter will state that their license to use the software is officially suspended. It will outline the statutory tied damages under Title 17, which can reach up to $150,000 per willful infringement. Since they have 24 machines running the software, that's a potential liability of $3.6 million if they try to crack the code." "Do you think they'll try to bypass it?" I asked. "If they do, they'll be committing a federal crime under the Digital Millennium Copyright Act," Robert said. Section 1201 prohibits the circumvention of technological measures that control access to copyrighted works. If Braden tries to have their new technician crack your encryption, we won't just sue them in civil court. We will file a complaint with the federal prosecutor. I thanked Robert, paid his retainer fee, and went home. For the next 3 days, I did nothing but work on my house. I painted the guest bedroom, repaired the deck, and went fishing. I made a conscious effort to keep my mind off Vanguard, but every evening, I couldn't help but log into my server to check the authentication logs. The logs were a beautiful sight. Every 2 minutes, the Vanguard local server IP address hit my authentication endpoint, returning a 403 forbidden status code. The requests were failing, machine by machine, as the local script tried to refresh its temporary verification tokens. By Friday night, all 24 Engel machines were running in factory default mode. Vanguard was currently running a high-volume order of GM harness connectors because they were using our old domestic H13 steel molds, which had excellent thermal efficiency. They were able to get away with the factory default settings for a short time. The scrap rate probably ticked up from 0.05% to around 2%, which was annoying. But not enough to trigger an alarm for Braden. But I knew that the Sinomold tooling was scheduled to arrive on Monday morning. Those molds were made of cheaper, less thermally conductive steel alloys. They were designed with narrower water cooling channels to save on machining costs. To run those molds successfully, you needed the precise real-time thermal adjustments that only my script could provide. On Saturday morning, my phone rang. It was an unknown number with a Columbus area code. I didn't answer. A minute later, a voicemail notification popped up. It was Braden Cole, his voice sounding slightly less confident than it had on Thursday. "Derek, this is Braden. We received a letter from your attorney. I think there's been a misunderstanding. Your software seems to be displaying a license error on our console. We need you to log in remotely and clear the flag. We have a major production run starting on Monday. Call me back as soon as you get this." I listened to the message, smiled, and deleted it. I didn't call him back. I had no obligation to answer his calls. I was obsolete, after all. On Monday morning, I woke up early, brewed a fresh pot of coffee, and opened my laptop to watch the chaos unfold through the remote telemetry logs. The first shipment of Sinomold tools had arrived at the Vanguard facility at 6 a.m. I could see the system activity spiking as their technicians mounted the new molds onto Engel Machine 12 and Machine 14. At 8:30 a.m., the temperature logs showed that they had initiated the heating cycle. I watched the thermocouple data stream onto my monitor. Because Holtkalib E4.2.Pi was running in factory default mode, the heater bands on the barrel were applying constant, static electrical current. They weren't adjusting for the thermal lag of the cheaper H13 steel alloy Sinomold had used. Within 20 minutes, the mold cavity temperature spiked to 320 degrees Celsius in the center, while the outer corners remained at 280 degrees. In the world of high-precision injection molding, a 40-degree thermal gradient is a death sentence. The first batch of glass-filled polycarbonate connectors was ejected from the mold. I didn't need to be there to know what they looked like. They would have severe sink marks, and the 48-pin alignment slots would be warped by at least 1/10 of a millimeter. I saw the operators cycle the machines again and again, trying to adjust the cycle times. The telemetry showed Engel Machine Cache 12 cycling at 45 seconds instead of the optimized 28 seconds, trying to give the plastic more time to cool. It didn't work. The scrap rate on the line was showing a staggering 45%. Through a friend who still worked in the shipping department, I later learned that Braden Cole had panicked. Instead of halting production, he ordered the operators to keep running the line and told the quality control inspectors to manually sort the parts. He was desperate to get the first shipment out to the Ford assembly plant in Flat Rock, Michigan, to meet the Monday afternoon deadline. They packed 50,000 connectors onto a freight truck and sent it on its way. By Tuesday morning, the truck had arrived at Ford, and the nightmare began for Vanguard. At 9 a.m., my lawyer, Robert Grant, forwarded me an email he had received from Julian Sinclair. Attached was a formal notification from Ford's quality assurance director. Ford's automated assembly robots had tried to press the electrical pins into the connectors, and the plastic housings had cracked. Out of the first 10,000 parts tested, every single one failed the physical tolerance check. Ford had rejected the entire 50,000-unit shipment. Worse, because the shipping delay left Ford without connectors for their afternoon shift, they had to halt the F-150 assembly line. Ford immediately invoked the late delivery penalty clause in our supply agreement. $50,000 per day, retroactively applied from Monday morning. They also threatened to charge Vanguard for the downtime of the assembly line workers, which could easily reach hundreds of thousands of dollars. Back at the Vanguard plant, Braden and Julian tried to bypass the software. Braden ordered Tyler, the 24-year-old technician they hired to replace me, to rewrite the Python code and remove the license check. But I had anticipated this. While the main wrapper script was written in open-source Python, the actual thermal math engine was compiled into a binary library file, holtcaliblib.pic, which was obfuscated and encrypted. When Tyler tried to comment out the API verification lines in the wrapper script, the compiled library detected the modification and triggered a safety lockout. The script didn't just fail. It sent a shutdown command to the OPC UA server, instructing the PLCs on all 24 Engel machines to go into emergency stop mode. The consoles displayed a critical error: invalid calibration engine, thermal protection lockout. Just like that, the entire factory floor went silent. Not a single machine could cycle. The plant's output dropped to 0. At 11:30 a.m., my personal phone began to ring. It was Braden. I let it go to voicemail. He called 3 more times, then sent a text message. "Derek, please pick up. The entire line is locked out. We have a crisis with the Ford account. I need you to log in and bypass the thermal lockout. We will pay you a consulting fee of $2,000 to resolve this today." I ignored the text. 5 minutes later, I received an email from Julian Sinclair, carbon copying his father, the CEO Harrison Sinclair. "Derek, we are experiencing an unexpected technical issue with the calibration software. As an employee of Vanguard, you are required to assist in resolving system issues. Please contact the plant immediately. Failure to do so will result in legal action for sabotage." I smiled and forwarded the email to Robert. Robert was ready. Within 15 minutes, he sent a formal response to Julian and Harrison Sinclair. "Dear Mr. Sinclair, my client Derek Holt is no longer an employee of Vanguard, having been terminated by Braden Cole on Thursday, July 16, for cause. Mr. Holt has no obligation to perform services for Vanguard. Furthermore, the calibration software in question is the sole property of Holt Precision Design LLC. Vanguard's license was suspended upon Mr. Holt's termination, as per the software license agreement. Any attempt by your technicians to modify or bypass the software's license verification constitutes a violation of the DMCA, 17 U.S.C., paragraph 1201. If Vanguard wishes to reactivate the software license and retain Mr. Holt's services to resolve the current production lockout, you must agree to the following non-negotiable terms. 1. Immediate payment of the contractually mandated software buyout fee of $250,000. 2. Payment of $100,000 in severance and back pay to settle all wrongful termination claims. 3. Execution of a consulting agreement between Vanguard and Holt Precision Design LLC at a rate of $300 per hour, with a minimum of 40 hours, $12,000, paid in advance as a retainer. Until these funds are cleared in our escrow account, the software license will remain suspended, and my client will not assist your staff." The ball was in their court, and their house was on fire. On Tuesday afternoon, Harrison Sinclair, the founder and CEO of Vanguard, took matters into his own hands. According to the shop floor supervisor, Harrison arrived at the facility unannounced. He didn't go to the administrative offices. He walked straight onto the shop floor. The silence must have been deafening to a man who had spent his life listening to the roar of hydraulic presses. He saw 24 angle machines sitting dark and cold, and a dozen operators sitting on crates, playing cards or staring at their phones. Harrison marched into the plant manager's office, where Braden Cole and Julian Sinclair were frantically arguing with a representative from Ford over the speakerphone. Harrison ended the call, locked the door, and demanded an explanation. Braden tried to play it off as a temporary software issue, claiming that I had locked them out maliciously. But Harrison wasn't an MBA spreadsheet watcher. He was a veteran engineer. He demanded to see the source code, the software license agreement, and the Sinomold files. He saw the contract Julian had signed, authorizing the purchase of H13 steel tools without any chemical certifications. He saw the scrap reports from Monday showing a 45% defect rate, and finally, he read the cease and desist letter from my attorney. Harrison realized that Braden and Julian had created a multi-million-dollar liability. Between the $50,000 a day penalty from Ford, the ruined polycarbonate resin, the idle labor costs, and a potential federal lawsuit for DMCA violations, Vanguard was looking at bankruptcy within a month. The fallout was immediate. Harrison fired Braden Cole on the spot for gross negligence and breach of fiduciary duty. He had security escort Braden out of the building with nothing but his personal tablet. Next, Harrison turned to his son, Julian. He stripped him of all operational authority, revoked his vice presidential title, and demoted him to a minor administrative role at a satellite warehouse, far away from the manufacturing floor. At 5:30 p.m. on Tuesday, my phone rang. This time, I answered. "Derek." Harrison's voice was tired, carrying the weight of a man who had seen his life's work nearly destroyed in a week. "I'm calling to apologize. Hiring Braden and letting Julian run the plant was the biggest mistake I've made in 40 years of business. I've seen the letter from your attorney. I'm not going to fight you. I'm going to agree to every single one of your terms." "I appreciate that, Harrison," I said. "But the funds must be in my company's escrow account before I log back in." "They will be," Harrison promised. "My bank is executing the wire transfer first thing tomorrow morning. I just need your word that you'll come back and get these machines running." Ford is giving us 48 hours to deliver a good batch of connectors, or they will cancel the contract entirely. Once the wire clears, I'll be there, I replied. At 9:15 a.m. on Wednesday, my bank app sent a notification. A wire transfer of $362,000 from Vanguard Injection Molding Corp. had cleared into the account of Holt Precision Design LLC. $250,000 for the software buyout, $100,000 for my severance settlement, and $12,000 as a 40-hour consulting retainer. I put on my work boots, grabbed my personal tablet, and drove to the plant. When I walked onto the shop floor, the atmosphere was completely different. The technicians and machine operators didn't look worried anymore. Several of them clapped and cheered as I walked past the tool and die bay. Tyler, the 24-year-old technician they had hired to replace me, was standing near the server cabinet, looking incredibly relieved. He handed me the server keys without saying a word. I sat down at the terminal, opened the configuration files for Holt Calib J4.2.py, and entered the new API verification key. I updated the system license parameters, shifting the software ownership from Holt Precision Design LLC to Vanguard Corp., as per the buyout agreement. Next, I turned my attention to the Sinomold tools. It took me 12 hours of continuous testing and calibration. Since the cheap Chinese steel expanded and contracted unpredictably, I had to rewrite the temperature offset algorithm. I modified the code to dynamically adjust the heating bands based on a nonlinear thermal expansion model, compensating for the poor thermal conductivity of the low-grade steel. By midnight, the scrap rate on Engel Machine 12 had dropped from 45% to a stable 1.5%. It wasn't the perfect 0.05% we achieved with domestic steel, but it was well within Ford's quality threshold. The parts were clean, the pins aligned perfectly, and the shipping department loaded the first truckload of certified connectors. I walked out of the plant at 2 a.m. on Thursday. The factory was roaring again, the rhythmic thud of the presses echoing through the cold night air. I stood by my truck, looking back at the building. Harrison had his factory back, and Ford had their parts. But the dynamics had changed forever. Vanguard now owned the software license, but they didn't own me. Every time they brought in a new mold, they would need someone to calibrate the thermal offsets and modify the script. And since Braden had fired their only in-house expert, they would have to hire Holt Precision Design LLC to do it. My new consulting rate was $300 an hour, and I was already 12 hours into my 40-hour retainer. I climbed into my truck, started the engine, and drove home. The corporate climbers had tried to play their spreadsheets, but in the end, the engineer walked away with the prize.